Alright, so a happy Saturday afternoon. I hope everybody had a good lunch. Let's get started. Now the question to you all, I sent out the list of topics that we're going to cover today. So I'm not sure who all got a chance to look through it. So I'll just read it out quickly. So today we are going to learn basic trigonometry and geometry related circle theorems. So when you talk about trigonometry, we call it unit circle theorem. When you talk about geometry, it's just a circle theorem. And this is where we'll talk about arc, length, sector and angles relationship. Then we'll talk about unit circle trigonometry. We'll talk about how do we convert, as part of unit circle trigonometry, we'll talk about how do we convert radian to degree and vice versa. And then we'll look at some of the trigonometric values of spatial angles. So a lot of things I told just now, nobody has to memorize that. We will see what it means on the board and then we'll take it from there. Okay. So anybody who is baffled right now thinking what we're going to cover today, don't worry about it. All that I said, that is to be forgotten. So anybody else joined while I was blabbering? I think. Okay. I see. Yep. What's your name, Vita? I see somebody with name. Unmute yourself and say hello to everybody, including me. Somebody with name Balsu Infi. Okay, you can probably introduce yourself when you feel comfortable. So we are starting now. So there are two parts. So we are going to learn about circle theorem with a geometry flavor as well as trigonometry flavor. Okay. So, yep, yes. Hey Nikhil, so you changed your display name and I got confused. That's okay. That's okay. So let's get started. So first thing is, let's talk about what is a circle theorem. What all do we know about circle? Circle is something which looks like the face of your teacher, pretty much, almost. This is a circle that we all know. Now, what else do we know about circle? Circle has a unique property where if I call this a center, this center is equidistant from each and every point on the circumference or the perimeter of the circle. Everybody knows about it. So this center is equidistant from all the points. Any point you pick up on the perimeter, it is equidistant from them. And this equidistant, or the distance between the center and any point on the perimeter, is called radius. Yep. And if you imagine a circle being divided into two equal parts, and again this line which is dividing into two equal parts is crossing the center again. So this is one radius and this is one radius. Here to here is one radius, here to here is one radius, because both the points on the opposite ends of the circle is equidistant from the center. So this is one radius and this is another radius, two radius, that is called diameter. Everybody knows about it, right? I'm just wasting everybody's time. I'm just reaffirming this. Yeah?
Yeah.
Now, why are we talking about it? Because we want to learn more than what we already know. So let's look at some more things that we already know and then we'll go from there. So this is a circle, almost like a circle. And we know that, okay, what is the area of the circle? Louder. Pi r square, right? Where if you have a circle, every circle is recognized by its radius. Smaller the radius, smaller the circle. Bigger the radius, bigger the circle. See, this is the radius. Now if I make a smaller circle, my radius becomes smaller. So if you know just the radius of a circle, that is more enough for you to know about the circle. how big or small it would be. And as we all know, area of a circle is nothing but the space that it takes on the surface where I am trying to draw it. Everybody with me, right? I am not saying anything new. Ria, is it making sense so far? I know this is your first class. Must be struggling with this old man. No? Okay. Alright. So this is the circle. We know that, okay, smaller the circle, smaller the radius, smaller the circle, bigger the radius, bigger the circle. Now, what is the area? Meaning how much space it takes? Area of a circle is known by the formula pi r square. And what is the circumference or the perimeter? How do you figure it out? Anybody? Anybody on the screen?
The circumference?
Circumference, yeah.
Diameter times pi.
Diameter times pi, yeah. So perimeter is diameter times pi, or we know the diameter is nothing but 2 times the radius times the pi, which is 2 pi r. I mean that's how we are representing the circumference, correct? So here as a very useless tip is, if you are talking about area, the 2 goes here. If you are talking about the perimeter, 2 comes as a multiplier of this. So pi r remains in the center. If you are talking about area, it goes here. If you talk about perimeter, 2 comes here. That's one dirty method of memorizing the formula if you want to. Now, that was not the intent. This is not circle theorem. Circle theorem is a technique in geometry which helps us figure out 3 things. One is called sector, second one is called arc, and the third one is called the angle it makes on the center. Now, can somebody tell me what is a sector? I'll come to you. Let me see if anybody is wanting to go on the screen. What do you mean by a sector of a circle? Or let me give you guys a clue. So this is my circle. Okay. Now what did I do? I just randomly picked 2 points on the perimeter and I joined them both with the center. Yes, Dhanusri.
A sector is like a part of a circle. Like,
yeah.
It's a part that's connected by 2 radiuses.
That's exactly what I drew here, right?
Right.
Yeah. Okay. So now, okay. Yeah, Dhanusri. Saying something?
No, sorry, that was on accident.
Okay. Anybody else? Now when you are seeing, so Dhanusri said that if you are looking at a sector, I mean if you are talking about a sector, it's nothing but 2 radiuses or 2 radii, making a part of the circle. Now, if I, again it depends on the way you look at things, right? If I look at from the top, I am looking at this sector. If I look from here, I am looking at other sectors, right? So anybody can define what's the difference between the two?
One sector has a acute angle, another one has obtuse, making the one with the it's the area of the sector differs, making one smaller, one bigger, or it could be equal.
Yeah. So you would not say that okay, one is acute, one is obtuse, because unfortunately, in case of a circle, both could be obtuse. More than 90, right? I mean, that's what is obtuse. So both. So in simple terms, you can say that the 2 radius splits the circle into 2 parts. One is a smaller sector, one is a larger sector, or it could be same also depending on what are those, where those points are. Yeah? Sarah, Neil, Shravya, Rehan, everybody with me?
Sir.
Yep. Okay. Ria, any doubts so far?
No.
Okay, Chris. See, I have a very bad habit of nagging everybody, okay? make sure that everybody in the class is with me. If anybody has any doubt, please feel free to let me know. Otherwise, I'll keep on checking with any and every one of you randomly. Okay, just to get the confidence that okay, I'm not talking to myself. Now, so basically, in summary, sector is nothing but an area or a portion of a circle made by joining two radiuses or two radii. I mean, I don't know how to pronounce it. You guys might know it better. Yeah. So, and then when you visualize this, one could be a smaller sector, one could be a larger sector. So to keep life little easier, mostly when we deal with it, let's say you pick up, let's say this is point P, this is point Q, and you randomly pick a point D here and a point E here. So when you talk about smaller sector here on this picture, you will say PDQ. Find out the area of sector PDQ. Then you would have no confusion that you are knowing about this side of the circle. If it talks about the sector PEQ, then you know that you are talking about the bigger part of the circle or bigger area within this circle. Yeah. Now, what is arc? I know Pranit has the answer ready made. Anybody else on the screen?
Is it like a piece of like the circumference?
A piece of the circumference, yes. Anybody else? Anybody else who has a different point of view? Chris, both the Chris are very quiet today. So is Nikhil.
Sorry, sir.
No, I'm just reminding you guys. You guys are very quiet. That's what I'm saying. Is everybody with me first of all, and then if you have a different point of view. No? Okay. Alright. So summary of that is, when you talk about a sector, you are essentially talking about the area. When you are talking about an arc, you are talking about the piece of the perimeter. It's essentially a length. So in mathematical terms, in geometry, right, when you look at any shape, you talk about two things, area and the perimeter. These are analogous to that. You're talking about sector, you're talking about the area, a piece of the area. You're talking about the arc, you're talking about piece of the perimeter. Yeah? Now this was the conceptual background to all this. Let's play with this. So, if I have a circle, let's say with a radius of 60 degree, not 60 degree, let's say 10 centimeters. And if I'm talking about two radiuses making 60 degree on the center, can somebody quickly find out what will be the length of the arc and what will be the sector of this circle? So again, I'm repeating my question. I have a circle with radius 10 centimeters and two radiuses are making an angle of 60 degree at the center. Find out the area of the sector and length of the arc. Don't find it out. Now can somebody tell me how would you go about it?
Is there a formula for it? So you do like 60 degrees over 360 degrees equals, it's like a proportion, and then you do...
You are certainly going the right direction. Yep.
And then...
I
don't know
the same things.
No, you know it already. You're just being shy. I'll come back to you later. Okay.
So the entire circle is 360 degrees. So if you want a sector of it, you use the sector angle, which is 60. So 60 degrees of 360 would get times your normal formula of 2 pi r over pi r squared would get you your arc or sector.
Right. So here's the deal. We know that, okay, if you want to know about a circle, you need to know about the radius. If you know the radius, you know everything about the circle that you need to know. Okay, that's one part of it. Now, the second thing that we all know, we have dealt with all different types of angles. We have dealt with all different types of angles. We have dealt with acute angle, right angle, obtuse angle, straight angle, whatnot. Here, in case of a circle, if you, I'm sure everybody knows, if you look at the entire angle that it makes, how much is that? 360 degree, like what Riya said and what Pranit also told. Any circle, if you look at the center, it's like one needle rotating 360 degree to make it a circle. Imagine or visualize your fan, the ceiling fan that we see. If you don't, let's say the fan is very interesting, if it has only one blade, then also it will rotate and make this, once the fan is turned on at a high speed, it will look like a circle, like what you are seeing right now. So your length of the blade is nothing but your radius. So for this to make a complete circle, or for it to look like a circle, this makes a 360 degree at the center, this blade, right, or this radius, whatever you call it. So that is what will be our second concept. There are only two things that we need to keep in mind. One is radius helps us define the entire circle, and it makes 360 degree at the center. Now if you look at this, no matter whether it's 60 degree, 80 degree, 40 degree, you don't really have to worry about it. It's like always like a piece of the pie. If you're talking about 20 degree, you're taking a small piece of the pie or a pizza. If you're talking about 40 degree, you're talking a little bigger piece. How big or small, or what proportion in which you are picking it up is a function of, okay, total. If I have to get the entire pizza, I have to get 360 degrees. What I got here, 60 degrees. So I'm talking about a piece of the pizza taken out, which is making 60 degrees. If I have to take the whole pizza, I have to make 360 degrees would have made one full pizza, or the entire area that this pizza takes. Now I'm talking about 60 degree. If it was 1 degree, how much portion I would have taken? This divided by 360 degree. I'm talking about 60 degree. So 60 degree value would be 60 times of what 1 degree would be. So it will be pi r squared by 360 multiplied by 60. So like what you said here, same thing. 60 by 360 multiplied by pi r squared. So you have to always look at what portion you are taking out, and that always depends on what is the value of the angle. So tomorrow if somebody says, I'm taking half the pizza. Half the pizza is nothing but half of 360 degree. 360 degree would have been pi r squared. You're talking about half the pizza, 180 degree. So you're taking 180 out of 360, and then whatever is the total area. Similarly, if I ask you guys, find out the length of this arc. This doesn't look like 60 degree by any means. But again, that is the courtesy my drawing skills. I'm saying this is 60 degree. This doesn't look like 60 by any means. This 60 degree will never be this big. But anyways, let's assume that your teacher is right. So in that case, how much would be, let's say we figured out what is the area, meaning how big the piece of the pie we are talking about. Similarly, if I ask you, find out the length of the arc, meaning from here to here, this is 60 degree, find out the length of the arc. How would you guys find it out? Same concept. The total arc from here to here makes 360 degree. I'm talking about only 60 degree out of 360. It will be the same thing. Total arc is how much? 2 pi r. Sorry, total perimeter is 2 pi r. I'm talking about, I'm not taking the whole thing. I'm just taking 60 out of 360. Done deal. Yeah? So area or sector, it might look like a very heavyweight problem. It is not. It is all about we knowing two basic concepts that okay, circle is the simplest of the shape that you can think of. See, if you're talking about triangle, you're talking about 3 sides. If you're talking about rectangle, you're talking about 4 sides. If you're talking about any quadrilateral, you're talking about 4 sides. Trapezoid, 4 sides but very unique behavior. You keep moving up, so many sides. Here, this is one of the simplest shape that you can always think of. It has only one property to remember, that is radius. If you know the radius, you're done. So, in case of a circle, we just have to visualize what do we mean by sector and what do we mean by the arc. As long as we know the sector and arc, as long as we understand what is meant by sector and arc, it is just a matter of visualizing how big the piece of pizza you want to take out from the larger circular pizza. Clear?
Yeah.
And that is how you can relate. Now let's say your teacher is just toying around with you guys. Meaning, teachers is not me always. There are so many teachers, right? And I would not be the one who would be setting questions for you. But when you deal with those questions, you will see that people will say, okay, my arc length is of the circle is, let's say, 18 centimeter. Okay? And the total perimeter of the circle is 54 centimeter. Okay? Find out the angle this arc makes on the center of the circle. Now, I did not talk about the radius. I did not talk about anything else. I said the arc length is 18 centimeter and total perimeter of the perimeter of the circle is 54 centimeter. Find out the angle it makes on the center. Any guesses? It is a problem that you will be able to solve in 15 seconds if you can relate. Who can give me the answer real quick without doing too much of calculation? Dave, very quiet today. Both the Chris's are also not talking. Give me your thought. I'm not interested in or worried about the answer right away. I'm just trying to read your mind. Let me read the question one more time. I'm saying the arc on a circle on the perimeter is 18. Arc of a circle is 18 centimeter. The total perimeter length is 54 centimeter. Find out the angle it makes on the center of the circle. Rehan, Shravya, Dhanushri, you guys are almost 1/3 of my age. You have to have more energy than me for sure.
Wait, what was the question? I'm sorry.
Okay, now I'm saying the length of the arc is 18 centimeter and the total perimeter of the circle is 54 centimeter. Find out how much angle it makes on the center. How much angle this arc makes on the circle. Now you guys will probably start thinking that you are actually overthinking. Now, as soon as I say this, anything, right? As soon as you look at a question, don't try solving it. First thing you'll do is, okay, circle. This is circle, and probably this is one arc. Let's say this arc is 18 centimeters. And the perimeter is 54 centimeters from here to here. Is 54 centimeters. The question here is how much angle it makes on the center. See, any arc would have two endpoints. What I'm asking you guys to figure out and tell me how much angle this arc makes on the center of the circle. This is what I'm trying to figure out. Yes, Chris.
For word two, what you can do is that you can take the arc as a numerator and then make the denominator the perimeter. So it would be like 18 over 54, and then you set that to like the angle you're trying to find. Let's call it x, and then that'd be x over 360 degree because the one circle makes 360, and then
I will write as you speak. Okay, you tell me what would I do?
so first of all, we write 18 over 54
Okay.
equals x over 360.
Yeah. Yeah. So this is the thing. X is the angle that makes 18. That makes the length of 18 centimeters. 360 makes the total length, total perimeter. Or these kind of problems, right? These one will never require you to memorize any formula. You have to always look at how do you visualize this and use basic calculation techniques. So if I were you, first thing which I keep talking about, and I'm sure many of the kids except Ria will start hating me if I do it one more time. This is my magic wand, okay? T stands for trust. Any problem that you pick up, trust that you can solve it. If there's anybody in the world who can solve it, that is you. R stands for read. Read the question a couple of times. And then A talks about analyzing the problem. You have read the question, you got what it is asking you to do, and then you analyze. You start putting your thoughts together. Okay, this is what I know, this is what is given, this is the formula I know, this is the concept I am aware of. So this is how I will do it. So you have just made your mind. Hey Vishal. So you have made your mind, and then comes N. N stands for Nike. What does Nike say? Just do it. Then you start doing it. So here the message is, as soon as you get the question, don't try solving. Read it 1 time, 2 times, 3 times till you are comfortable. Analyze, meaning put your thoughts together, and then you start solving it. You'll not go wrong. Or your chances of being right is more. Okay? Vishal, you missed the initial part of the speech. Can you hear me okay? Vishal, are you able to hear me okay? Okay. Alright, I'm assuming you are able to hear me. You are just on mute. So anyway, we are learning circle theorem right now relating to geometry. And once we cover that part, we'll go to unit circle theorem relating to trigonometry. Okay. So we have just talked about what is sector, what is arc, and what is the angle, and what is the relationship among them. So since you all know what do you mean by area of a circle, what do you mean by perimeter of a circle, we are just trying to extrapolate or extend that understanding to relate that with sector and arc. Now coming back to the point, Ria, Chris and everybody, right? You guys told me that okay, you will do 15 by 54 equal to x by 360, and then you will find out the angle. I will do it in an even simpler approach. Even simpler, I mean, and result will be the same, but this is how I'll do it. Okay. So this is when I read the question. Arc is 18 centimeter, perimeter is 54 centimeter. Find out the angle it makes on the center. Okay. Arc is this much, perimeter is this much. Find out the angle it makes on the circle. So see, I have started making a picture in my mind. That okay. So this is saying that this is a circle, and arc is nothing but 2 points on the perimeter. Yes, Vishal.
What are we doing in today's class?
So we are learning circle theorem. That is where we'll talk about sector, arc, and angle relationship, and then we'll go to trigonometrical side of it, where we'll talk about the unit circle theorem, and we'll go from there. Yeah. So are you aware of what is a sector and what is an arc, Vishal? Okay. Then you're not going to miss anything, or you'll not be blindfolded with respect to what we're doing. So this was a question that I had given, that I have length of an arc given, I have perimeter given by in the question. I have to find out how much angle it makes on the center. So after reading this thing so many times, I am making a picture of that. So I said, okay, fine. So I have this is the arc, and I have to find out how much angle it makes. I don't know what it is, so let's figure it out. Now, as soon as you see this, you say, okay, fine. I have the total perimeter given and I have this thing also given. So, let me just find out this angle. So, if I was talking about the entire perimeter, I was talking about 360-degree angle, which is 54. 360 degree was making 54. Okay? Okay, or I will put it this way. Say, okay, fine. 54 centimeter was attributing to 360 degree, which is the whole perimeter, I mean, of the circle. So, if I am talking about 1 centimeter, what I am talking about? It will be 54th part of this angle. So, if I am talking about 18, how much that will be? That will be whatever is the value of 1, multiply that by 18. Done. So, this is exactly what you would have got Chris also. That okay, 18 by 54 equal to x by 360. So, if you have to keep x on one side, so you have to move this guy goes up. It becomes 18 into 360 by 54. Same thing, same problem, just done two different ways. Why I took this approach was this way. See, I have to find out what? I have to find out the angle. What is known as the arc length and the perimeter. So I will, whatever is to be found out, I will keep on the right hand side. Okay? Whatever is known, I will keep on this side. So that way, I say, okay, 54 centimeter makes this much, 1 centimeter will make this much, so 18 centimeter will make this much. So both the options are there. You guys can think about it doing about it in the way you are comfortable, but ultimately there is no complex logic in this one. It's just about how do you structure your thoughts, how do you visualize it, and then you do it. Was that too long a speech?
No.
No?
That's good.
Yep. Everybody with me? Alright. So so kids who have been quiet. So Rehan, Dhanushri, Savya, Sarah, Neil, Vishal, Chris was not quiet. Smandi was quiet. Everybody comfortable with whatever we have done so far?
Yes, sir.
Okay. Now, see, with age, this is where it gets interesting. I got glasses to see things better. Now with so many grey hairs, I see better without glasses. So that's the interesting part of it. Let's look at one question that I had pasted in this one. This question says, let me put this question here, okay? I will let you guys, nobody should put effort for solving it, okay? I'm not really interested in figuring out how do you 12 times 5, okay? Or how do you do 8 times 9. That is something that you guys would have championed by now. I'm more interested in figuring out what is your approach, how do you construct your thoughts. So this is the question, okay? This is a circle and I have, okay, this is A. I'm not doing anything fancy right now, okay? I'm just writing it down. This is O, this is not 0, okay? And this is C. Obviously, as you guys can see, this is the center, and this is X. It says in the above figure O, if the center of circle, in the above figure O, let me read one more time. In the above figure, O is the center of the circle. What is the value of X? What you are given is this. Okay? You are given this angle is 50 degree. You have to find out the value of this angle. And you are told that this is the center. Okay? There is no more information to this. It is all about how creative, how thoughtful, how you can get and how you visualize this. I will give you guys 2 minutes to think about it before I open my mouth. If anybody is ready, don't be shy to raise your hand. Okay. Okay. Exciting. All right. Let me not get everybody else biased. I'll still give 2 minutes to everybody else. Okay. So that everybody gets their due chance to think about it. So Vishal and Dev, just hold it for a minute. Okay. I'll use that same time for drawing the next picture for the next question actually. Don't even look at that part, okay? Okay. Now, let's see what. No? Okay. Let's see what Dev has to say. Yep, Dev.
Okay, so we know that like
Ignore whatever is here on this side, okay? Just here.
Okay.
Yeah.
Okay. Oh wait, what does the middle letter say at the center?
O.
Oh yeah. So we know that O to A to C create that creates a 50 degrees, and since like O to A is the radius, we know O to C would be the same. So then angle C also creates a 50-degree angle, and all angles add up to 180. So we would do 180 minus 100, which gives us 80. So angle O is 80, and since the circle creates 360, it would be 360 minus 80 for x.
So Vishal, did Dev steal your opportunity to speak the same thing? Vishal is sad now. Vishal, did Dev grab your opportunity to say the same thing, or you had a different point of view?
I was thinking of the same way.
The same way. So this is the thing, okay? This problem looked little cryptic to begin with, but this is where my most boring technique can be leveraged again. Keep reading it, keep staring it, keep stalking this question, okay, till you get tired or the question gets tired of you. When you look at this question carefully, okay, this is the sentence. See, every information that you have in the question, there is a reason for it, there is an intent for it. You are given this angle, and then this question says, O is the center of the circle. The only property about circle we know is center of the circle is equidistant from every point on the perimeter. As soon as you know that this is the center of the circle, oh, that means any point I pick up will be same length. So this and this will be, these two will be same length. Oh, we are talking about isosceles triangle. If the two sides are same, the two angles have to be the same. So then we know, okay, this is also 50 degrees as Dev and Vishal mentioned. So this is 50, this is 50. So the first clue was isosceles triangle. As soon as you got that, then you know my triangle can never have sum of all the angles different from 180. So then you could figure out this is 80. 50 plus 50, 100. 180 minus 100 is 80. This is what you are left with. So this is making 80 degree here. Now there is nothing to figure out. Now, this question is history. Everybody understood this, right? Nobody has any doubt about whatever Dev and Vishal explained, whatever I just copy pasted. Everybody clear, right? Rehan?
Yes, sir.
Rehan, Neil, Sarah, everybody clear? Smarni, you're okay, beta? You're not talking at all. Smarni, okay? Yeah. Yeah. Okay. So this question is history now. Let's forget about this guy. Let me zoom in the second question. And this time I promise I will not talk. I will let one of you do it and only that person will explain. And maybe I will not even talk about that question. I will just validate if the answer is correct or not. And then I'll let you guys explain. And then after that I will give you guys one nice lecture, nice speech, which I love doing. All the kids who have been victim of being taught by me, they know that I love giving speech. So I will give us another speech today. Let's see. So this is a muted question, it doesn't say anything. It just has given you a circle and it has given you this angle and saying find out this angle. So let's see who can do it. And then whoever does it will have to explain to the whole class. And I'll tell you why I'm insisting on doing that. Riya, the last question was understood, right? I mean, last one, whatever we discussed and explained, that was understood?
Yeah.
Okay. Now let's look at this guy. And again, trust me, only clue for you guys is there is nothing complicated about it. Math is never a complicated subject, trust me. Yes, Riya.
So it's basically like the last question, right? So the one triangle on the left is equivalent to the other one, and so is like the angles of O. And so you could do 35. The angle of B is equal to the angle of C, so it's also 35.
Yeah, 35. So there's a theorem for that. Okay, there's a circle theorem for that.
It never specified that point is the center of it. So. And
Did I?
you
Okay.
didn't say anything.
I did not say anything about it. Okay.
So there's no specific point there.
Okay. Yeah, probably. Yeah, I should have mentioned that this point where these two are meeting, this is the center. I mean, that's one thing I missed. I mean, I did not even write O, but Riya explained that in a very crisp way, saying that it will be this angle and this angle will be same, and there is a theorem for that. That's one of the circle theorems, okay, which we are not going to right now. Probably we'll come to that later once we try proving it one more time. But we'll go with a very simpler approach. So Riya's approach is perfectly fine. I want to hear anybody else in the class also to give me an even much simpler solution. So only mistake I made was I did not say that this is the center of the circle.
Hi, sir.
Yes, Dhanushree.
So simply I have to leave a little early, if that's okay.
Yes, sure. Only thing is, whoever leaves early, the only penalty is you have to watch the video of the remaining class. Yep.
I love it.
Yeah. Okay. All right. Yeah. Anybody else? Yeah.
So that theorem would say, using that theorem we can find out that A, B, and CD would have been equivalent, and then since the center angles are vertical angles, they would be equal to. And then that would also leave you with so that would be one angle. The angles are equivalent and the sides are equivalent. So that means if you can
You're saying these two triangles are equivalent?
like congruent.
Congruent. Yeah, that's the right word.
So you'd find out that the two sides are equal, like they're congruent, and using the theorem you'd find out A, B, C, D.
Right.
A, B, and then C, D are equal, leaving you with SSS.
Right. So here there are three solution approaches that I've heard so from you guys. And that's what makes me redundant. You guys don't need a teacher like me. You already know it. And what are those options? Simplest of the option, okay? If I'm solving it like a baby, I'll not even think about congruence. I'll not even think about the circle theorem. I'll still go with the first approach to begin with, and then we'll come back to second and third one. This and this are radius, so this is isosceles triangle again. This is 35, this is 35, makes it 70. This is 110. This is 110, so this is 110. Opposite angles. If this is 110, again this is isosceles, so this becomes 35. This becomes 35. This is one approach. Second approach that Riya said, that was that okay, there is a theorem which says if you have 2 points on the circumference, the angle that it makes on any place on the periphery is half of the angle made on by this on the center. So that means any point you pick up, if the two end points of the arc are these two, be it this angle or be it this angle, they will be same because both are half of the angle made on the center. So angle, let's say this is the two end points of this arc. This is the angle made on the center, which is double of this angle and double of this angle. So this angle's double is this angle's double is this. That means both the angles double is same. That means these two angles have to be the same. That was the second approach. Third approach that Pranit brought in was that okay, fine, let me not worry about this. This looks congruent because you have, these are two intersecting lines. Opposite angles will be the same. These two angles are same. This is radius, this is radius, this is radius, this is radius. So you have this side, and the angle between them matching between the two triangles. So SAS angle, theorem of congruence says these two are congruent, meaning these two triangles are exact replica of each other. Now, that means, now again, these two sides being same, that means this is isosceles triangle. So this angle and this angle are same. So when they are congruent, regardless, both the angles are 35 degrees. You don't really care. If this is 35, this will be 35 only. So for the same one simple, cute problem, you guys had 3 different ways to solve it. And that's essentially it comes down to. And this is why I was saying that I'll give you guys a speech. That this is on a very constructive note. I always encourage all my kids. When I say all my kids, I mean each one of you, okay? I have so many kids. So here, what I recommend is, when you come across any problem, when you solve something, don't keep it to yourself. Discuss with somebody. When you solve it, right? See, I'm super excited when I heard 2 different or 3 different approaches of solving this problem. When I'm sharing it, these 3 options everybody in the class has now. Depending on which one you find more convenient or easy to digest, you'll adopt that one. And that becomes your takeaway. So my only request or the theme of the speech is get into the habit of sharing. I've not seen kids sharing what they learn with their friends. If you find some difficult problem, ask somebody, okay, this one I'm not going to solve. Do you have an approach for this one? Go and ask. There's nothing wrong in doing that among your friends. Because when this old man teaches you, I will have my own orthodox way of teaching things. When you teach, when you discuss among your friends also, you will find some innovative, some more recent approach of solving the problem as well. And then you have multiple options, right? I mean, this old man telling you something versus you learning something by yourself, something learned from your friends. Put these things together and see what best works for you, right? We might be able to solve this problem in any which way, but you always have to figure out which is the fastest and the most efficient and the foolproof solution approach. Correct? That's why, long story short, whatever you learn, if you feel like bragging about something that you have learned, share with your friends. Say, see, I learned something. I want to show you. You might be knowing about it, but just wanted to share. Because when you tell somebody, when you explain somebody, you're actually becoming a teacher by yourself. And when you teach something to somebody, that becomes your biggest strength. Because now for me to be able to teach you guys, I don't know what kind of a student I was when I was your age, but when I'm trying to teach you guys or when I'm daring to teach you guys, I have to be more clear with my own concepts. So that is why when you get into the habit of teaching or explaining something to somebody, that makes your concepts even stronger. Okay, that was the theme of the speech that I was talking about. Get in the habit of sharing. You will see a lot of benefit coming your way. You're not helping your friend, you're helping yourself. Your chances of going wrong gets minimized. Okay? Yeah? Keep writing about things, that's okay. You learn something, even if it could be your friend will say, oh, this is a very easy one. Doesn't matter. You practice, you revised. Yep. Does it make sense, or you think it's a very old school way?
I know it makes sense.
Okay, wonderful. So now let's look at one more problem. What I'm thinking is unit circle theorem we will pick up tomorrow, okay? Because that will be a much loaded concept. So let's pick up. Okay, so converting radian to degree or degree to radian. That is not something I'm wanting to teach you guys because you guys already know it, right? But still, for the sake of recording this as an evidence that I have taught you guys, I'm putting it on the screen. 360 degree is equal to how many radians? 2 pi radians. That's it. Now, if somebody says pi radian, 360 by 2, 180 degrees. If somebody says pi by 4 radian, pi by 4 is what? 180 by 4, 45 degrees. So you can interchangeably relate to them just by knowing this. So basically now if you look at the whole circle, half of this is pi radian and this is the second pi. So this pi has 2 pi's inside it. Okay. So that's the conversion that everybody should. This is just a formula. This is just a relationship between the degree and the radian way of looking at the angles. Okay. Anybody having any doubt around this one? Or anything that is not clear? Yeah. Like we measure length in meters and also inches, right? I mean, we can measure in centimeters or we can measure in inches, right? If you remember your scale, one side you will see centimeters, one side you will see inches. So likewise, there are two different scales for measuring angles. That's how, and in trigonometry it becomes even more commonly used. That's why, I just talked about it. All right. Anybody having any question with respect to whatever we have learned so far? No? So tomorrow our focus will be on unit circle theorem. That is where we will talk about the trigonometry side of circle theorem. Okay? Yeah? All right. So I'll let you guys go. Enjoy the rest of your evening and see you guys tomorrow same time.
Thank you.
All right. Yep.
Thank you, sir.
All right. Bye-bye. Bye-bye.
Thank you, sir.
Yep. Bye-bye. Okay. Who is here? This is Suhina. Welcome to the class.